Hi children. In our previous lesson, we focused on the definition of fractions and learned about the types of fractions. We explained what fraction means with figures and studied some terminology. In today's lesson, we'll again focus on meaning and continue to develop the concept of fractions with shapes. Before this lesson, check if you know all the definitions and terms covered in our first fraction lesson. Do you know all these terms now coming? Fraction, do you know this? Proper and improper fractions, like and unlike fractions, unit fraction, mixed fraction, and numerator and denominator of a fraction. If you know all these terms, then you started to this subject very well. If you have any lack on these definitions, on these terms, all the meanings of all these terms, please repeat the first our fraction lesson. Watch the same video again, please. Now let's continue with the next page and show our first question. Now our title is here fractions with models or fractions with figures, shapes. Okay, but the best one is models here, fractions with models. Now the first question on this subject, write the fraction represented by each tape diagram. Now, here I have a model, I have a whole rectangle, Now let a bit repetition make. From our previous lesson, we told that a fraction has two parts, namely numerator and denominator. The number on the top is called the numerator and the number on the bottom is called the denominator. The numerator defines the number of equal parts taken, whereas the denominator defines the total number of equal parts in a whole. Now, in this picture, my whole is this rectangle, and this rectangle was divided into 1, 2, 3, 4, 5, 6 equal parts, and only one of them colored or shaded. Now I'll speak about the shaded region. Express the figure as a fraction on the shaded region. Express the shaded region as a fraction. Okay, my main question is this. Now let's write as a fraction. Writing denominator is very easy. The number of all equal pieces of the whole. We counted before 6. And what about numerator? The number of equal parts taken, or here shaded, only 1. So I should write here 1. 1 represents the number of shaded region. 6 represents number of all equal pieces of the whole. What about the second one? Number of all pieces is 4. Number of shaded region is 1, so it's 1 over 4. Number of all pieces of the whole, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. And the number of shaded region is only 1. So we showed you all figures as fraction on shaded region, and 1 over 6, 1 over 4 and 1 over 10 are unit fractions, you know, from our previous lesson. Now let's continue with the next page. On the next page, of course, same kind of questions we have. And please, let's read the question. Observe each tape diagram and write the fraction of the shaded and unshaded portions or parts. Shaded. Now, shaded part. I should write the shaded part as a fraction. Now, number of all pieces, 1, 2, 3, 4, 5, 6, 7. I should write here 7. Number of shaded parts, 1, 2, 3, 4, 5. 5 shaded. So my fraction is 5 over 7. What about unshaded part? Now, number of all pieces of the whole, equal pieces of the whole, is 7. We know from our first fraction. The number of unshaded parts, 1, 2, 2, as you see, 2. 2 over 7 represents the unshaded part of this whole. What about the second question, shaded part? Number of all equal pieces, 1, 2, 3, 4, 5. 5 is, so 5 should be written on as denominator. What about the number of shaded parts? 1, 2, 3, 4, 4. So 4 over 5 represents the shaded parts. What about unshaded part? 5 is all and only 1. You know, you see from the figure, only 1 I have shaded, not unshaded part. Now let's continue with the next page. This question differs from the other last two questions because last two questions were on about the proper fractions. Proper. It means the number on the numerator. The number on the numerator is less than the number of denominator. Okay. And let's come here. My main shape here is this circle. And let's concentrate on the first circle. It's my whole. And a whole is represented by 1. Okay? By 1. So this whole is 1. What about the shaded region? How can you show this shaded region or express this shaded region as a fraction? Number of equal parts of the whole is 1, 2, 1, 2, 3. So my fraction appears now. 3 is its denominator. What about the number of shaded parts? How many? 1, 2, 3. 3 shaded. So all shaded. It means 3 is also numerator. So 3 over 3 is 1. It means clean, and this is 1. This is 1 again. 1, 1, 1. And this is also 1. The last one is not 1. Number of all equal parts of the whole is 3. Number of shaded region is 2. So the last one is 2 over 3. So I have 1, 2, 3, 4, 5, and 6 as a whole number. Whole number. Whole number is a part of mixed fraction, you know, from our previous lesson. So I have 1, 2, 3, 4, 5, 6 as a whole number, and 2 over 3 is fraction. 2 over 3. 6 and 2 over 3. So this type of figures show us a mixed number. What about the second one? 1, 2, 3, 4 whole number. And what about this? I should concentrate on the number of shaded region. 1, 2, 3, 4. All of them 4, 5, 6, 7, 8, 9. So 9 is denominator and 4 is shaded number of shaded region, or here written on denominator. 4 is numerator, sorry, not denominator. 4 is numerator, 9 is denominator. So 4 and 9, 4 over 9 is our mixed number for this figure. I think you understood this type of models. Write the numerator and denominator. This is whole. How many equal parts, how many equal pieces? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is denominator. What about the shaded parts? Number of shaded pieces is 8. So 8 over 9 is our fraction for shaded region. What about this? 1, 1, 1, 2, 3, and 4. I have 4 equal pieces of the whole. So I should write here 4. Denominator is 4. What about the number of shaded region? 1, 2, 3, 3. So 3 is the numerator of this fraction. 3 over 4 is our fraction for the second shape or model. Let's come to the fifth question. Now observe the shaded portions in each fraction model. Fill in the missing numerator or denominator. Now I have this whole and I divide it into 2 equal parts, and one of them is colored 1 and 2. There are 2 equal parts in whole, so I should write here 2. Only one of them shaded, so here is 1 written. What about this? I have 2 shaded region, so I should write 2 on the numerator, and denominator is 6 given all number of equal pieces of the whole. What about this? Numerator is unknown, so I should count the number of shaded equal pieces. 1, 2, 3, 4, 5, 6. I should write here 6, and 9 is all equal pieces of the whole written here. What about this figure? 3 is the number of shaded region and 4 is the all equal pieces of the whole. So I should write on the denominator 4. 4 is the denominator, the number of all equal pieces of the whole. Now let's continue with the next page. Color the models to represent the mixed numbers. 3 and 2 over 4. So I should color 3 circles, all circles, like this. 1, 2, and 3. What about the last one? Now these 3 shaded all parts or pieces of each circle represents these 3 circles represent the whole 3. What about 2 over 4? The last circle should represent the fraction part of this mixed number, 2 over 4. I should color 2 pieces only. So what about 9 and 1 over 2? I should color all 9 circles like this. 1, 2, 3, 4, 5, 6, 7, 8, and 9. I colored all parts, all pieces of each circle. So each represents 1. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 1. So these colored circles represent the whole number part or whole number of this mixed fraction. What about 1 over 2? 1 over 2 should represent, its fraction part of this mixed number, 1 over 2. It means color only one part of the last fraction. It represents 1 over 2. Now let's continue with the next one. 7th question. Which of the following models represents the fraction 3 over 4? 3 over 4. So I should find 4 equal pieces, or I should count 4 equal pieces of the whole. For example, for choice A, 1, 2, 3, 4. Yes, okay. But for the choice B, 1, 2, 3, 4, 5. So it's impossible. It cannot be answered. For choice C, 1, 2, 3, 4. I have 4 equal parts of the whole. It's okay. For the last one, I have 1, 2, 3 equal pieces of the whole. It's also impossible. So D and B cannot be answered. And what about 3? What about the numerator of this fraction? 3 over 4. Numerator is 3. It means I should count the number of colored pieces, or the taken pieces, 3. And the first choice A, 1, 2, 3 equal pieces shaded, as you see. So the answer is A. What about C? Only one piece colored. Only a piece colored. 1 of 4 pieces colored here. So C cannot be the answer. What about the second one? Which of the following models doesn't represent the fraction 5 over 8? I should count in all 8 equal pieces, and I should see 5 of them colored. Let's start from choice A. 1, 2, 3, 4, 5, 6, 7, 8. 8 is okay. What about 5? 1, 2, 3, 4, 5. It's okay. The answer is does not. This represents the fraction 5 over 8. So the answer cannot be choice A. What about this? In total, 1, 2, 3, 4, 5, 6. It's not 8. So this model doesn't represent 5 over 8. This is the answer. What about C? 1, 2, 3, 4, 4, 8. 8 is total number of equal parts of the whole. What about 5 colored? I should see 5 colored pieces. 1, 2, 3, 4, 5. This is okay. C also, the fraction on C also represents the fraction 5 over 8. What about D? 1, 2, 3, 4, 5, 6, 7, 8. 8 is all number of equal parts, equal pieces of the whole. And what about the number of colored pieces? 1, 2, 3, 4, 5. It's also okay. 5 over 8. This figure or model shows the fraction 5 over 8 for shaded region. So B is the answer we told before, and today's lesson is over. we reached the end of the course. Hope to see you on the next lesson. Bye.